Okay, now let's look at area is some other kinds of shapes. How about we look at area of a pentagon? And we're going to look at the area of a regular pentagon. And I'm not any good at drawing them, but we will see. Remember what a regular polygon means. A regular polygon means that all the sides are the same size. All sides have the same measure. So naturally, calculating the perimeter of a polygon is really, really easy, because if you calculate the perimeter, if it's a regular polygon, all you have to do is, in this case, it's a pentagon, so it has 5 sides, 5 times whatever the measure of the side is, and let's say it's 8 feet. So it'd be 5 times 8 is equal to 40 feet. And that would be the perimeter. The area of a polygon is a little bit different. What we need to know for the area of the polygon is we're going to look at the triangles that make up this polygon. There are going to be 5 equal triangles with all their vertices meeting in the middle. And so what we need to do is calculate the area of one triangle and then multiply that times the number of triangles you have. And that's true no matter what your polygon is. The number of triangles times the area of one triangle. And that's if it's a regular polygon. So I have no idea what it should be, but we're going to pretend that this is 6 feet, and we're going to let this be 4 feet. It may not actually be a good accuracy, but we're going to do it that way. So we're going to figure the area of this triangle, multiply it by 5, and we can do that as long as we have a regular polygon. So this would be 1/2 base times height. My base is 6, my height is 4. So 1/2, my base is 6, and my height is 4, which is going to equal 12 square feet. That's for one triangle. But that's only one. There's 5 of them in this, so we're going to go 5 times 12, which is going to give me 60 square feet. So that's how you're going to calculate area within a pentagon or any other triangle that we have. One thing that's really interesting to look at is what is the area of an equilateral triangle. And remember, an equilateral triangle is a triangle that all the sides are the same length. So if this is 6 feet, this one is 6 feet, and this is 6 feet. Okay? But we need to know what this height is. Okay? We can figure that height. Why? This height goes right into the middle of the base. So that means this is 3 feet, and this one is 3 feet. So we can calculate our height using the Pythagorean theorem, which is 6 squared is your C, and A squared we don't know, plus 9 squared, not 9 squared, but 3 squared. So A squared plus 9 equals 36. A squared equals 36 minus 9. So A squared equals 16 minus 9 is 17, 27, yeah, 27. So A is going to be the square root of 27, which is approximately 5.2. Let's see what it is. Square root of 27. How about 5.19? Hey, not too bad. 5.196, so we'll round it to 5.2. So we therefore have a 5.2 is what this height is. So once we know the height, now we can calculate the area of this particular triangle. So it's 1/2 times times 6 times 5.2, which is going to be 3 times 5.2, which is 6, 15.6 feet squared. Okay? Now, if you have a regular hexagon, I believe that every triangle in a regular hexagon happens to be an equilateral triangle. So that's an interesting thing to know that. Therefore, if you'll notice, this square root of 27 simplifies exactly times 3 times the square root of 3. So if we have an equilateral triangle, half of the base times the square root of 3 is what is going to be the height of an equilateral triangle. So the height of an equilateral triangle equals 1/2 base times the square root of 3. So you can always calculate that on an equilateral triangle. 1/2 of the base times the square root of 3. All right, so that's one of the things that you can do. There's some really kind of interesting things that happen with these various kinds of polygons and the shapes that you end up with them. If they're not regular polygons, they can be very, very complex in calculating the area of a polygon. One of them that I set up had this is not a regular polygon, as you can see. And I'm not drawing it very good. That's a little better. Oh my, I'm really off. There, that's a little better. All right, irregular polygon. So as we look at an irregular polygon, this happens to be a hexagon. We've got two, these are going to be the same here. Let's say this is 3, 4, 5. Let's say this is a 10 feet, 10 feet. This one here is 10 feet and 10 feet. Notice, if we look at this 10 feet, again, this is an isosceles triangle. Isosceles triangle, the perpendicular, which gives the height, divides this into two equal-sized pieces, and the same down there. One thing to notice though, my hypotenuse is 10 feet exact. The only thing that's going to give 10 feet exact is a right triangle that is a 3, 4, 5, a multiple of 3, 4, 5. This would be your hypotenuse. So if this is 10, this has to be 8, and this has to be 6. So we have two possibilities here. One is 6 and the other is 8, or vice versa, because my hypotenuse is 10. And I'm going to make these 16 feet. So we have a rectangle that is going to have a length of 16 feet and a height that could either be 8 and 8 or 6 and 6, depending upon which way you decide. If I decide to make this one 8 feet, then this has to be 6, and this one has to be 6, because this is a 6, 8, 10, 6, 8, 10 right triangle. And the same thing is true over here then. So I have a 16 by 12 rectangle, which will give you one of your areas. And I have 4 triangles. And remember, in a right triangle, the base and the height are these two sides. So you have 1/2 base times height, and there's 4 of those. So that's going to give me 2. So 2 times base times height, which is 2 times 6 times 8, 2 times 48, which is 96 square feet. So in these triangles, I have 96 square feet. So therefore, adding this and this together, I have 72 plus 96, which is equal to 168 square feet. If we chose the other direction, what would it be? Well, if we chose that, instead of 6 by 8, now this would be 8 by 6. It doesn't change the amount of area in the triangles, but it does change the amount of area in my rectangle. So this would be a 16 by 16 rectangle now, which is going to give me 256, I think. Yep, 256. 256 square feet. So 256 plus 96 is 12, 10, 15, 352 square feet. So as you can see, the way you decide these two pieces changes what your answer is. And both answers would be acceptable in this case. You just have to indicate which one it is. So as you can see, the area of a hexagon, when you're dealing with something like this, is very different from dealing with a regular hexagon or a regular pentagon. A regular hexagon would be just like that regular pentagon I did, where you figure that you calculate the area of one triangle and then multiply it by 6. And you have some of those, at least one of those in your textbook that you're going to look at. Okay, so that gives you some different ways to look at different shapes of areas and what it would be. As you see, the perimeter on those are not hard because it's just all the way around and you're given the information you need, but the area gets a little bit sticky in some of these. Now let's look at some other things. What would be the area of this circle with a square inside? Okay, the radius of the circle is going to be 10 meters. Okay, so what do we have here? What if we don't know the side of that square? Well, remember, we can use our Pythagorean theorem because this diagonal, this side and this side is the same square. So you've got x squared plus x squared is equal to, this is 10 from here to here for the radius. So my diagonal will be 20 meters. So this will be 20 squared. All right. Now, what's that side going to be? Well, this is 400 to x squared divided by 2. And my x squared equals 200. Now, x is equal to the square root of 200, which I think it might be about 14 point something. Let's look and see. Yeah, 14.14. Okay, so one side is 14.14 meters, and that's the same for this one, 14.14 meters. Now that we know the side of our square, we can now take the area of the circle and subtract the area of the square from it, because we want to know what the area of our shaded areas are. Okay? So let's do that. Area of the circle minus the area of the square is going to equal the area of the shaded area. Okay? So area of the circle, pi r squared, which is 10 squared, 3.14 times 100. So this is 314, okay? Square meters, of course. And then minus area of my square is 14.14 times 14 by 14. Remember, it's side squared. So guess what that's going to give me? That's going to give me 200. How do I know that? Because the square root of 200 was 14.14. So if I square that, I'm going to go right back to there. So that's 200. And now I'm going to have 114 square meters. That's how much is in the shaded area. So you can do all kinds of different things with that. Oh, let's see. There's a bunch of different ones. What else could we do? Let's look at this one. What if I have an 18 by 18 inch square? And across the middle, I have 3 cans. I didn't get it very evenly divided, but anyway. And each one of these cans has a radius of 3 inches. How much area is in the shaded area? Everything outside the cans. How much area is in there? Or the circles, everything outside the circles. So we need to know the area of the square minus the area of these 3 circles. So area of your square minus area of the 3 circles. Okay, so area of the square is 18 times 18. Area of one circle is 3.14 times 3 squared. And then we're going to multiply that times 3 because there's 3 of those circles. 18 times 18 is 300 something. Let's see, I think. Yeah, 324. Minus 9 times 3.14 times 3. And it's going to give me 84.78 inches squared. Okay, 324 minus answer is going to give me 239.22 inches squared. So as you can see, there's a lot of different things we can do in area that make it really kind of a lot of fun as you look at area. All right? So there you are with a lot of looking at area from different perspectives. Have fun.